Okay, test number 2 starts in section 1.5, and 1.5 is all about quadratic equations. Make sure you go and print the notes for this chapter so that you can follow along with these videos, and kind of breaking them up a little bit into smaller chunks, smaller topics for you guys. Hopefully that makes it a little bit easier. So let's just talk a little bit about quadratic equations. We're going to go into quadratics a lot in this class. So let's just talk a little bit about the different parts of a quadratic. So right here, this is the general form of a quadratic. So ax squared plus bx plus c equals 0. Our highest exponent is this 2. We have an x squared. We have a, which is always with x squared, b is always with x, and c is always our constant. Okay, we always have these pieces in some way. Okay, and then if we look at the graph, we've seen this U shape before. Remember, this U shape is called a parabola. That's the shape of the graph. And it is symmetric. So this is kind of called it's called the parent function. You don't really have to remember that, but when we have this point here on the origin, this is called the parent function. Notice it's symmetric with the y-axis, meaning if I folded it along this y-axis, it would lay exactly on top of itself. So this point right here would lay on top of this point would lay on top of this point. So you can kind of see the different pieces of the graph over here. We've got the U shape, the parabola, okay? This point right here, it's called the vertex or the turning point. So in this case, this is where it goes from decreasing back up to increasing. And sometimes they're flipped this way. And this is where it goes from increasing to decreasing, from increasing to decreasing. But this is also, this is also called the vertex here, okay? We also have these points right here. These are called roots. They actually have a lot of different names. Roots, these are actually all the names right here. Solutions, roots, x-intercepts, and zeros. It all means the same thing, but this is where they are located on the graph. It's where it crosses the x-axis. And then we have this imaginary line that runs through the vertex. It's called the axis of symmetry. And that's where that line, if you fold it in half or along that axis of symmetry, will lay exactly on itself. Okay, so this is just like a basic run through of quadratics. Now what this section is about is finding these points. Now these points are called the roots, but they're also called solutions. So chapter 1 is really all about finding solutions to equations. So this section is finding solutions to quadratic equations. And there are lots of different ways that we can find solutions to quadratic equations. Now, solutions are called roots, x-intercepts, and zeros, and we'll refer to them in all of those different ways. In this section, we'll refer to them mostly as solutions, okay? The first method that we're going to talk about, though, is factoring. So factoring, a lot of people do it a lot of different ways. And so I do something called the X method. So remember, we need to start in general form. So let me just write it down here since it's there. So we want to start in general form. Okay, so I start by drawing an X. Okay, and I put C goes on the top, C goes up here. And then I put B on the bottom. So -9, whatever sign is with there goes on the bottom. So now I want to think, what are the factors of C? So factors of C that add to give me B. Okay, so 14, you may already know what they are already. The factors are 1 and 14, 7 and 2. I could also think of -1, -14, -7, -2, right? You can't forget those negative factors. So I want the combination that's going to add to give me -9. So in this case, 7 plus 2 gives me +9. So -7 plus -2 is going to give me that -9. So -7, -2. So I've got my factors. So I'm going to break down this quadratic into 2 sets of parentheses. And this is what I put, x minus 7, x minus 2. So this is called factored form. Now these are not the solutions. These are just the factors, okay? This is factored form. Now to go from factors to solutions, we apply something called the zero product principle. It says if something times something equals 0, then one of those somethings or both of those somethings has to be 0. So I can split them apart and say, well, this one could be 0, or this one could be 0, or they could both be 0. And so then I have 2 simple equations to solve. So here I'm going to add 7, I get x equals 7. Here I'm going to add 2, I get x equals 2. So these are my solutions. Okay. So we found our factors, wrote it into factored form, split them apart, and found our solutions. Now number 2, we're going to do that same process again. But for number 2, we have to put it into general form first. So notice we've got x squared over here by itself, but we need these guys to come over here. We want to try and keep x squared positive if we can. So I'm going to subtract 8x and I'm going to add 15. And that's going to bring them over to the other side. So it's going to become x squared minus 8x plus 15 equals 0. So here's my x. C goes on top. B is -8. Remember, B is always with the x. So let's come down here, and I want the factors of 15. Let's just list them. 1 and 15, 3 and 5. Let's do the negative as well. And I need it to equal -8. So I'm going to choose this pair right here. -3, -5. So I'm going to write it in factored form. X minus 3, x minus 5 equals 0. All right, I'm going to write that here. Factored form, because on your homework it'll ask you for factored form, so I want to make sure you know what that is. And then from factored form to solutions, split them apart, set them equal to 0, and solve each smaller equation. So add 3 here, you get x equals 3. Add 5 here, x equals 5. So our solutions, I think on the homework it says solution set. And it'll have a little squiggly bracket like this. It might even say x equals that. 3 and 5. Okay. All right, so number 1 and number 2 were when a, or that coefficient of x, was 1. So now let's look at some where that is greater than 1. So we have to do a different process. And it has kind of a cutesy name, sorry, but it does. It's called slide, divide, bottoms up. And the bottoms up part is sometimes optional, okay? And you'll see why. So still step number 1. And I'm going to try and write the steps out. Maybe that will be helpful. Step number 1, general form. You still have to put it in general form first. So that means I'm going to move everything to the left here. So I'm going to add x, and I'm going to subtract 2 to bring it over this way. So it's going to become, and let me come up here so that I have lots of room. 6x squared plus x minus 2 equals 0. I just moved those terms over to the left side. Okay, so now I've got a number here that's not 1. I've got something else there. So my next step is to divide by a. So I'm going to divide every single, no, not divide, I'm sorry. I'm getting ahead of myself here. Not divide. The first step is slide. Slide A, not divide. Slide. Slide A. There we go. That looks better. All right. We're going to slide A to C. And that's A times C. So A times C here. So we end up with x squared plus x. 6 slid over to negative 2. So that's negative 12 equals 0. Okay, so it's sliding over to C. So now I've got something that looks more like example 1 and 2. So I'm going to factor it like I was factoring number 1 and number 2. So let's draw a little x here. So we're going to factor using that x method. So remember, C goes on the top. So C here is negative 12. B goes on the bottom. Now, if there's nothing in front, that's a 1. So let's figure out what our factors are for negative 12 that are going to give me a positive 1. So 12, or negative 12, has a lot of different factors. So negative 12 would be 1 and negative 12, or it could be 12 and negative 1, 3 and negative 4, or 4 and negative 3, 6 and negative 2, or 2 and negative 6. So we need the combination that adds to give me a positive 1. So in this case, it's going to be 4 plus negative 3. That's going to give me a positive 1. So that is the combination that I'm going to use here. So x plus 4, x minus 3 equals 0. Okay, this next step is the one that everybody forgets. Okay, so step number 4 is really important. Everybody forgets it. And this is divide by a. This is the number that you slid. Okay, so x plus 4, but I'm going to divide by 6. X minus 3, but I'm going to divide by 6. Oops, but I wrote a 4. Let me fix that. Let's see. No, I don't want to clear it. Wants to be slow on me here. All right, we'll just write equals 0. So let's put an arrow here. So we know this is the step that's really important that everybody forgets, and we don't want to forget it. So we're going to divide by A, simplify. And I know this seems like a lot of steps, but eventually it'll just become second nature, and you can do several steps at once. So I'm going to reduce these fractions. So 4 over 6 becomes 2 over 3. 3 over 6 becomes 1 over 2 equals 0. And this is kind of the optional step occasionally. So this is bottoms up. And I'll show you why this is sometimes optional once we get finished. So anything that's left as a denominator, so sometimes when you simplify, you get a whole number. But if you have anything left as a denominator, the bottom comes up to the front. That's why it's called bottoms up. So this becomes 3x plus 2, and this becomes 2x minus 1 equals 0. So now this is factored form. So we did all of that, and we've gotten into factored form. And to get to solutions, we do the same thing we were doing before. We split them apart, set them equal to 0. So 3x plus 2 equals 0. 2x minus 1 equals 0. So I'm going to subtract 2. I get 3x equals negative 2. Divide by 3. X equals negative 2/3. Over here, add 1. 2x equals 1. And divide by 2. X equals 1/2. So my solutions are here. Right there. Now, let me show you why bottoms up is sometimes optional. So if you take a look right here at this step, before we did bottoms up, if I were to take x plus 2/3 and set it equal to 0, and x minus 1/2 and set it equal to 0, I could get my solutions from this. I could get that negative 2/3, and I could add 1/2 here and get positive 1/2. Okay, I could get the solutions. However, this step is not factored form. So if you are asked for factored form, you have to do the bottoms up step. If you're not asked for factored form, you can go directly from this green step right here with this green arrow to solutions. And I hope that wasn't too confusing, but if I can save you some work, then I would like to. Okay, so I'm going to erase this green because I want to have space for the next problem, but bottoms up is optional unless you're asked for factored form. So let me just write that under that step. So bottoms up, use when asked for factored form. Let's put that. Otherwise, you can go straight to solutions. So it'll let me delete this. Not letting me use the eraser. Same reason. All right, so those are kind of our traditional factoring methods. So there's some other factoring that you will do. So if we look at number 4, I'm going to choose a different color. Number 4, notice we have an A term and we have a B term, but we have no C. So we're going to factor it a little bit differently. We don't have to do the X method. We don't have to do the slide divide. We can actually just factor what these two terms have in common. So we can factor out a 3 because we can take out a 3 from the 3 and the 9. And they both have an X in common. So if I take out a 3x, I'm left with x plus 3 equals 0. And if you want to check if you factor this correctly, you can kind of mentally say, all right, if I redistribute this, am I going to get the same thing as what's up there? So 3x times x would give me 3x squared. 3x times 3 would give me 9x. So I know that I factored it correctly. So now this is factored form. So I can split these apart and set them equal to 0. Well, 3x equals 0, x plus 3 equals 0. Divide by 3, x equals 0, subtract 3, x equals negative 3. So those are my solutions. These are way easier to factor, take much less time. And then number 5. Let's do red. Now number 5, we have an A term and a C term, but this is no B term. And we actually, this is not technically factoring at all, but I wanted to put it in this section in case you see a problem where there's no B. So we actually are going to solve this just like an equation that we were solving in section 1.2. We're just going to get x by itself. So let's start by adding 8. So we get 3x squared equals 8. Divide by 3. X squared equals 8 over 3. But I don't want x squared, I want x. So remember, to undo a squared, I take the square root of both sides. Now I want some extra room, so I'm going to come up here. So that's x equals the square root of 8 over the square root of 3. Now I'm not allowed to have a radical in the denominator. And by the way, when you take the square root of both sides, we have to add this plus or minus on the outside. We'll learn more about that down here in the next video. So we've got plus or minus square root of 8 over the square root of 3. And we can't have this radical 3 on the bottom, so we have to rationalize the denominator. So to do that, we just multiply by square root of 3 over square root of 3. And you're going to multiply by whatever radical is in the bottom. So on the bottom, you end up with just a 3, or whatever's on the inside. Square root of 8 times square root of 3 is square root of 24. And we can't forget this plus or minus. And then to simplify radical 24, let's see, this is going to be 2 radical 6 over 3, plus or minus 2 radical 6 over 3. And that's going to be our solution right there, solutions. So plus or minus means positive 2 radical 6 over 3 or negative 2 radical 6 over 3. And you can write it either way. Now when you're typing this into MyLabs, this little symbol right here is just, it should be in, there's like a little keyboard at the bottom that you could pop up and use that symbol. And you can use that, or you can write it as 2 separate answers there. It's up to you. All right, so in the next video, solving using the square root method, you'll learn more about the plus or minus. Technically, example 5 is the square root method, but we use that when we have no B term.